A very long time ago, from atop this small blue planet, floating on the edge of a vast galaxy, one being never stopped lifting its eyes toward the heavens, toward that void that seems endless there, toward the universe that grows wider the more we try to understand it. Humans, since the dawn of time, have not viewed the sky as a mere distant spectacle. They have viewed it as an open question, a question that has never lost its allure. Rather, it has deepened with every new discovery. Is life on Earth a rare occurrence? Are we a cosmic exception? Or is our existence here just one version of a greater probability, a probability that might be repeated in places we cannot yet imagine? It may seem to us that Earth is everything because we live upon it. But the truth revealed by modern science says something completely different. Our location in space is not as special as we long imagined. The sun is not the center of everything, nor is the Earth the axis of existence. And humans are not the finale where the story stopped. Every time we take a step in understanding the universe, we discover we were overestimating our place in it. We have examined our moon with precision. We have explored the terrain of Mars. We have tracked the grooves of its surface. And we have sent a spacecraft roaming the solar system, approaching everybody that could grant us an answer or pose a new question. Meanwhile, our telescopes have been observing much further than that, revealing to us worlds we never knew existed in the first place. Planets orbiting other suns, new worlds. Some are rocky, some are unbearably hot, and some may perhaps hold the conditions suitable for life. So far, we have discovered nearly 6,000 planets outside our solar system. And each one does not represent merely a number in a scientific record, but a new possibility. A possibility that might lead us one day to find another Earth. But the real question is not whether we will find a planet like Earth. Rather, will this planet be inhabited? And here, the true story begins. While scientific missions continue their journey across the Milky Way, huge facilities on Earth are dedicated to a goal no less ambitious than interstellar travel. Listening to the universe and searching for any sign that might reveal we are not alone. We are not just looking for life. We are looking for evidence, for a message, for an intelligent pattern in this majestic cosmic silence. We have already sent a fair number of signals into space, signals carrying our fingerprint, our location, our curiosity, and our deep desire for someone to answer us. Anyone. Or if there is a civilization watching this corner of the galaxy, then perhaps it has already seen us, and perhaps it has replied in its own way. And we just haven't understood how to hear it yet. And yet, even so, we cannot limit the possibilities of life to a single form. Scientists today are not looking for creatures resembling humans, but for any possible form of life, from the simplest bacteria to creatures that may live in harsh conditions, reaching up to advanced civilizations that may have preceded us by thousands or millions of years. More excitingly, some worlds we deem unsuitable for life may actually be among the most promising. Not just the planet itself, but moons as well. Especially the icy moons that hide beneath their frozen crusts, potential oceans, and secrets that could completely change our understanding of life. But amidst this terrifying vastness, the most difficult question remains. How do we define a habitable world? How do we distinguish between a silent planet and one hiding life we do not recognize is. And how can we communicate with something we don't even know how it looks, how it thinks, or what it wants? Even more importantly, is this thing looking for us at all? In every corner of this world, scientists are working to narrow the distance between us and the answer. They observe, analyze, measure, and reconstruct the picture piece by piece, hoping that one day we will reach just a single moment. A moment where we discover that the question that occupied humanity for thousands of years is no longer a question. Are we alone in this universe, Daya? Man has always raised his head to the sky, carrying this question within him. By observing the movement of celestial bodies, we learned how to measure time, and how to build calendars, and how to organize agriculture, and how to understand the rhythm of life on Earth itself. For the sky was, to us, not just distant space. It was a great clock, a guide, a map, and an arena. It shaped our beliefs and influenced our religions and formed our view of our place in existence. And in ancient times, the world seemed very simple to us, and perhaps arrogant too. We placed the Earth at the center of the universe, and we made the sun, moon, stars, and planets all revolve around it. And why not? We saw the Earth standing still beneath our feet. We see the sun moving in the sky, and we see night and day alternating in a way that suggests we stand exactly in the middle. But what we see with the eye is not always enough to understand the truth. In the 15th century, the old view began to crack. Then the first telescopes came to turn everything upside down. Suddenly, the sky was no longer as it was in the imagination of ancient man. The moons that appeared in the lenses began revolving around Jupiter, not the Earth. And here began the first real collapse of the idea that man stands at the heart of everything. Then came Copernicus, Galileo, Newton, and others. To open the door to an intellectual revolution, it changed the position of the Earth, the position of the sun, and the position of man himself within this universe. And the revelation did not stop there. After the sun displaced the Earth from the center of the picture, we discovered in the early 20th century that the sun itself is not fixed, and it is not a center for anything. Rather, it moves through space at tremendous speed, carrying with it the Earth and everything upon it. We do not stand in a fixed place as we imagined. We are rushing, traveling, and moving within a universe much larger than our imagination allows. And the sun in the end is just one star, among hundreds of billions of stars embraced by our galaxy. And the Milky Way itself is just one galaxy among numbers that almost exceed the ability to conceive. Countless galaxies, innumerable stars, and secrets that accumulate as our observation tools expand. But even these staggering numbers are not the end. Between 2003 and 2004, scientists pointed the Hubble Space Telescope toward a spot we thought extremely small in the sky. It didn't look at first glance like more than a narrow black square amidst vast darkness, yet what appeared there later was enough to redefine the very meaning of the void. Because this place, which we thought was empty, was not empty, not at all. After pointing it for a full 1,000,000 seconds toward a small dark spot in the sky, a spot that seemed completely empty, something happened. No one was prepared for it. New lights appeared. Not one star nor 10, but thousands of luminous points that had never been seen before, before. And the amazing thing is that each of those points was not a star, but an entire galaxy. An independent galaxy containing billions of stars within it, and perhaps billions of worlds too. After analysis, scientists discovered more than 100,000 galaxies, 100,000 mini-universes, inside an area of the sky that could be covered by a pinhead if we held our arms up. Only then did humanity begin to realize the true scale of what it was facing. Great science fiction writer Douglas Adams described this feeling in a way that was painful and precise at the same time. He said, "These discoveries gave us answers, but in return they opened huge doors to existential questions we were not prepared for." In ancient times there was a kind of reassurance. Earth was the center of the solar system, then the center of the universe, then the center of all creation. And that meant something very important to humans, that everything was designed for them, that this planet has a purpose, and perhaps every human on it has a purpose too. But science began to gradually take its centrality away from us. Suddenly, Earth was no more than a small planet on the outskirts of a lost galaxy. And our galaxy itself is just one among hundreds of billions of other galaxies spread across a universe that seems boundless. Suddenly, our size was reduced to something like a cosmic speck of dust. This realization was never easy. It is what is known as the mediocrity principle, proposed by Nicolaus Copernicus. The idea that our location in the universe is not special in any exceptional way. But the most dangerous question was not just about Earth, but about humanity itself. If our location is not special, are we special at all? When we look at the massive numbers in the universe, this question becomes even more confusing. Hundreds of billions of stars and hundreds of billions of planets. How, amidst all this vastness, can we believe we are the only instance of life? According to modern estimates, the observable universe contains at least 100 billion galaxies, and each galaxy contains about 100 billion stars on average, and most of those stars have planets orbiting them. This means we are talking about a number that the human mind can barely comprehend. A 1 followed by 22 zeros of potential worlds. At this point, the probability that we are alone seems like an impossible miracle. That is why the scientific question today is no longer, does life exist outside Earth? Rather, it has become, where is it? And from here begins one of the most mysterious questions in human history. If we discover life beyond our planet one day, what would that mean for us? What would happen to politics, to religions, to our idea of ourselves, about the meaning of civilization, and about the meaning of being human? A discovery like this would not be just fleeting scientific news. Rather, it is a moment that could completely reshape human consciousness. As decades passed, the possibility of finding other life turned into a real obsession. It dominated the minds of scientists, and perhaps even the greatest minds the 20th century has known. In 1950, during a lunch break inside the Los Alamos laboratory where scientists previously worked on the Manhattan Project during World War II, the great Italian physicist Enrico Fermi sat down and asked a question that would later become the history of in the history of science. A very simple question, yet terrifying in its meaning. Where is everyone? The paradox that baffled Fermi was clear. If the universe is this vast and if the probabilities of intelligent life are this high, why do we not see any trace of it? But before trying to answer, we had to first face a harsh truth regarding the status. The universe is not just vast, but vast in a way that makes communication almost impossible. Take, for example, the closest major galaxy to us, the Andromeda Galaxy. It is separated from us by a distance of approximately 2.5 million light-years, meaning that if you could travel at the speed of light itself, which is the fastest possible speed in the universe, you would need 2.5 million years to reach it. We are not talking about a long journey, but about numbers that break the very concept of human time. That is why scientists realize that the search for life cannot include the entire universe, at least not yet, kada. We must start from our small cosmic island, from our own galaxy, must I? But even this small neighborhood we live in, known as the Milky Way, is not small at all. It is a massive playground that extends across 100,000 light-years, and it contains hundreds of billions of stars. Almost every star has a different story, a different world, and perhaps a different life as well. Somewhere within this cosmic darkness, there might be another civilization looking at the sky right now, asking the same question: are we alone? Are we alone? Based on this observation, we return again to the question that seems simple in its phrasing, but is perhaps the most complex question humanity has ever faced. Are we alone in the universe? When Enrico Fermi asked his famous question, he wasn't just wondering if life existed somewhere far away within this universe. Rather, he was wondering about something much more strange. If alien civilizations truly exist, and where are they now? Why don't we see them here in our galaxy, right before our eyes, or perhaps already among us? Imagine for a moment that this giant tree represents the Milky Way galaxy, and that every leaf on it represents an independent star. Hundreds of billions of leaves and hundreds of billions of stars. Now imagine that an intelligent civilization appeared on one of those leaves. A civilization that succeeded in exceeding the boundaries of its planet, then developed advanced technologies that enabled it to travel between the stars. In the beginning, it would explore only the systems closest to it. Then it will gradually expand, star after star, world after world. Over time, this civilization will spread across the entire galaxy like a constantly widening wave. And when scientists ran the calculations, the result was staggering. Even if this civilization moved at relatively modest speeds compared to it would only take a few tens of millions of years to explore an entire galaxy. This number might seem huge to us, but in cosmic terms, it is virtually nothing. To understand this, imagine the following. 150 million years ago, there were no flowers on Earth at all. And just 3 million years ago, humans as we know them, had not yet appeared. In just the last 800,000, humans have gone from lighting their first fire to landing on the moon. All of this happened in a nearly insignificant blink of an eye in the life of the universe. That is why Fermi saw that the odds seemed confusingly clear in view. Out of the hundreds of billions of stars within our galaxy alone, and over the more than 10 billion years of its life, it seems almost certain that another civilization must have emerged somewhere. A civilization that evolved and thrived, perhaps millions of years ahead of us. And if it ever managed to master interstellar travel, it is theoretically supposed to have been able to colonize the entire galaxy within a relatively short period. It should have even reached us as well. It was supposed to be here by now, but it is not here. And this is the point where the Fermi Paradox crystallizes. The shocking contradiction between the enormous odds of the existence of intelligent life and the eerie cosmic silence we face at this moment. More than 70 years after the question was posed, the paradox remains. All calculations say that we cannot be alone. Yet we have not found any definitive proof of extraterrestrial life so far, even as the numbers keep mounting. Regarding the vastness of the universe, we face the reality of the mediocrity principle. There is no trace of signals nor evidence of intelligent life. Nothing but suspicious cosmic silence. This is the point where the Fermi Paradox crystallizes to pose its eternal question, where is everyone? Fermi believed the matter was very simple. If there were truly advanced alien civilizations, we would have found evidence of them by now. But perhaps it is not that simple. Perhaps other civilizations do exist, but they have not tried to communicate with us. Or perhaps they have sent signals we have not yet been able to understand. Perhaps they are observing us silently, just as a biologist observes an ant colony without interfering. There is even a stranger possibility. What if they have already found us and decided it is best to leave us alone? This idea is not pure science fiction. It is one of dozens of hypotheses through which scientists are trying to explain this great silence. But before we assume the universe is ignoring us, we must first acknowledge a very important fact. We ourselves have barely begun to search. For even now, we have not actually left the borders of our solar system except symbolically. The farthest human-made spacecraft took only about 30 years to reach the edge of the solar system and begin its journey into interstellar space. Only 30 years to exit our small cosmic neighborhood. But the closest star to us is further. The Sun is more than 4 light-years away. By current standards, it would take humans tens of thousands of years to reach it. This is where the real problem begins. Perhaps the dilemma isn't the lack of alien civilizations, but that the distances between stars are so vast that the universe appears empty, even if it is teeming with life. Perhaps at this very moment there is another civilization on the other side of the galaxy, pointing their devices toward the sky and asking the same question we have been asking for thousands of years. Where is everyone? At this rate, our current spacecraft might take more than 20,000 years to reach the nearest star. As for crossing the Milky Way galaxy in its entirety, it might take hundreds of millions of years. And here, the truth becomes undeniable. If we are currently unable to go to the stars, we must make the stars come to us. Not in body, but in signals. That is why humanity had only one option to master: the art of observing the sky. No matter how small we are in the vastness of this universe, we still possess an exceptional quality that should not be underestimated. The ability to observe and to understand. That is why our journey to search for life did not begin with interstellar travel, but by looking at the stars with unprecedented precision. If we want to track down an alien civilization somewhere in the galaxy, we must learn how to read the universe itself, how to decode the light coming from the depths of space and turn it into information clues and punastahus and potential messages. We may not be able to reach distant stars, but at least we can observe them, analyze the light emitted from them, and read what it hides within. Unlike our ancestors, we have freed ourselves from the constraints of direct vision and what lies just before our eyes. Is just before. We have discovered that light is not just something that illuminates the world around us, but a highly complex wave traveling at nearly 300,000 kilometers per second. More importantly, light vibrates and oscillates at different frequencies, and these vibrations are what create the colors we see, from red to violet, many go violet. But what our eyes see is only a tiny fraction of the truth. Some types of light vibrate so rapidly that they become invisible to us. Like ultraviolet rays, X-rays, and at gamma rays. Conversely, there are other types that vibrate very slowly, like infrared microwaves and radio waves, waves. And although we cannot see them, they remain light. Light that carries information, and sometimes entire secrets about the universe. That is why humans had to go beyond the limits of their natural senses to build new eyes. Eyes that can see the invisible. And thus modern telescopes were born. Giant structures mounted atop distant mountain peaks, far from urban interference and the noise of Earth. Some spread massive mirrors in the heart of deserts while others are sent into space itself, thousands of kilometers to offer planet to sight. We no longer look at the sky in the old way. We have begun to see it in entirely different wavelengths. A whole new sky. Though with every light frequency we succeed in detecting, another part of the universe hidden from us all along is revealed. Some bats are millimeters. We revealed, in fact, some of the planets we have discovered were never seen directly, but we detected their existence only through light. But before we go too far, we must stop at one of the most important weapons scientists rely on in the search for life. Homes, commercial radio waves. It is a widespread form of invisible light, filling the universe in every direction. In fact, we are surrounded by it right now. Radio waves constantly cross the atmosphere, passing through our bodies, reaching the Earth's surface from the depths of space. Yet they are extremely weak, faint to the point of almost disappearing, perduring amidst the vast cosmic noise. The physical processes that emit these signals occur at unimaginable distances, and that is why we need exceptional tools to detect them. Tools so massive it is hard to believe. Is unheard of in the Africa. Giant telescopes use concave mirrors and huge metal structures to focus signals coming from space, just as a lens focuses rays of light. And the goal is not just to capture the signal, but to analyze it too. Because every wave carries information, and somewhere within this cosmic noise it might carry the trace of another civilization. In the heart of France, amidst the quiet forests of Sologne, the Paris Observatory operates one of the largest radio telescopes in the world, a massive metal structure stretching for about half a kilometer. Above it looks like a machine out of science fiction novels. At its ends, giant steel meshes act as massive mirrors or radio waves onto waves. Their function is to redirect signals coming from deep space, then focus them toward a central point inside the structure, where the most important stage begins. The stage of listening to the universe. Because scientists are not just looking for starlight, but for something far stranger. A signal that seems unnatural. A signal bearing an intelligent pattern. A signal that could be, for the first time in human history, evidence that we are not alone. At its core, it is a very simple engineering concept, but its implementation reaches a level that is almost fantastical. When radio waves coming from deep space hit these giant metal mirrors, they are reflected horizontally along the Earth's surface with amazing precision. Whoa! Before striking the main mirror, which refocuses them toward a single focal point in J. There, in the heart of this massive structure, the signals from the universe begin their final journey. Radio waves are converted into electrical signals. Computers can analyze and decode them, extracting the information hidden within. The matter might seem very technical, but in reality it is like trying to listen to the whispers of the universe itself. Through this precise analysis of electromagnetic signals coming from the furthest reaches of space, Scientists have begun to discover phenomena that no one knew existed in the Milky Way galaxy. Radio waves revealed massive clouds of interstellar gas and dust. In regions where new stars are born silently within the cosmic darkness. It has also shown us in incredibly mysterious objects, such as pulsars, dead stars spinning at insane speeds, emitting regular radio pulses in its haze, to the point that scientists initially thought they might be signals from an intelligent civilization. But more importantly, radio waves are not actually strange to us at all. We ourselves have relied on them every day for over a century. Waves have allowed us to build an entire world of communications. From radio and television broadcasting, to navigation systems like GPS, to the smartphones we now carry in our pockets, almost the entire modern world moves over an invisible sea of radio waves. And here a very important question arises. If we, as a relatively young civilization, have managed to use radio waves in this way, is it possible that other civilizations have done the same? This is the essence of one of the most famous scientific projects in the history of the search for extraterrestrial life. The SETI Project. The idea is simple and frightening at the same time. For over 100 years, humanity has been constantly broadcasting radio signals in all directions. Radio programs, television broadcasts, military communications, messages, songs, movies, news. Almost everything we have done over the past century has not remained on Earth. It has actually left it. Because radio waves travel at the speed of light, which is about 300,000 kilometers per second, and they do not stop at the edge of the atmosphere. They continue expanding year after year like a cosmic bubble carrying trace of our existence. In other words, our entire existence is now floating in space, and at this very moment, there are signals from Earth crossing distant star systems, carrying with them human voices, languages, music conflicts, and even their most ridiculous moments. That is why, if there is a civilization observing this part of the galaxy, it may have already seen us and might know more about us than we imagine. But the most terrifying question is the opposite. If other civilizations truly exist, are they also broadcasting similar signals? If the laws of physics are the same throughout the universe? And as a catch-as, And if technology develops according to the same principles, then perhaps other Tibeto civilizations have gone through the same stages that we have. Perhaps they discovered electricity, then radio. Then they began to broadcast their signals into the sky without realizing that someone might be listening, which is why scientists today ampliapo the endless hours, observing the sky, not searching for spacecraft or mysterious lights, but searching for something much simpler, a signal, an unnatural pulse, a mathematical pattern that could not be created by stars, black holes, or natural phenomena. A signal that says only one thing: someone else is here. Is here. But so far, despite all the telescopes, all the giant antennas, and all the long years of listening, the universe remains silent, or perhaps we just do not know how to listen yet. Natas bohunachka. If there is an advanced alien civilization, even if it has reached a level close to or even slightly below our technical civilization, it is highly likely that it has discovered something we also discovered a long time ago. Onda suendi, radio waves. For they are not only an effective means of communication. In fact, it is also one of the simplest forms of signals, which can be produced and acted across vast distances. That is why many scientists believe that any intelligent civilization attempting interstellar communication might naturally turn to radio waves. But here, an intriguing question immediately arises. Could we one day pick up an extraterrestrial TV broadcast or a phone call from another world? Unfortunately, it is not that simple. While it is true that our radio signals constantly leave Earth, they spread out in all directions. As they expand, they weaken at an enormous rate. By the time they reach deep space, they become so faint that detecting them over long distances becomes nearly impossible. The same applies to any other civilization. However, physics offers us a potential solution here. Instead of broadcasting randomly in all directions, a signal can be focused into a narrow, intense beam, then directed straight toward a specific star here. Just as a flashlight's light differs from a laser beam. And here, real hope begins. Perhaps there is a civilization somewhere far away that decided long ago to send focused signals across the galaxy, not for noise or random broadcasting, but with a clear, specific goal: communication. For this reason, for more than half a century, radio telescopes around the world have been working non-stop, scanning the sky day and night, searching for any signal that might appear intentional, any message, no matter how small, even if the planet that sent it is invisible to us. But here, a more complex problem arises. If an intelligent signal did reach us, would we even know it was intelligent? The universe is not as quiet as it seems. There are billions of stars, black holes, nebulae, and pulsars on. All of them constantly emit different types of radiation. Even if we only focus on radio waves, which are the most suitable for communication, the sky is still filled with immense cosmic noise. This is why scientists are not just looking for any signal, but for a signal that carries information, a signal with a pattern, with meaning, a signal that looks as if someone created it deliberately. One of the simplest ways to send information, for example, is using regular pulses, like in Morse code. A single pulse might mean one thing. 2 pulses could mean something else. 3 pulses, then silence, then a repetition. Only then does a wave turn into a message. But if the signal is perfectly constant and does not change over time, we would certainly be able to detect it. However, it would not carry any information. That is why what scientists are truly looking for is a modulated signal. A signal that changes in a way that nature alone cannot explain. In 1967, it seemed for a moment that humanity might have finally found something like that, Mona. Perfectly regular radio pulses arrived at Earth from a fixed point in the sky. They were so regular that they stunned scientists. Some even jokingly called them little green men. But the truth was even stranger. It was the first discovery of what is known today as pulsars. Ultra-dense objects rotating at immense speeds emitting precise, regular radio flashes like a giant cosmic clock. Then, just 10 years later, something even more mysterious happened. In 1977, a radio telescope in the U.S. state of Ohio picked up a short, amazingly strong signal. A signal unlike anything known. It was strong, organized, and coming from the depths of space. When the astronomer responsible for analyzing data saw it, he wrote one word next to it. Just wow. And from that day on, it became known as the wow signal. But the problem is that it never repeated. We could not observe it again, and we still don't know its true source today. That is why it remains one of the greatest mysteries of modern astronomy. After more than 50 years of careful observation, we are still without conclusive proof, no confirmed message, no direct contact, no answer. Only possibilities and silence. Only possibilities and silence. But in the face of vast cosmic silence, humanity decided on something bold. If the universe isn't talking to us, then perhaps we should be the ones to talk. And so, scientists began sending their own messages to the stars, with giant radio telescopes taking on the task of gathering signals and focusing their waves. And focusing their advanced engineering structures is to be directed later toward distant space targets. Simple messages, yet laden with great meaning or meaning. Mathematical sequences, logical patterns, prime signals. Any intelligent civilization, no matter how different from us, could realize they are not a product of nature. They are a declaration of existence, an attempt of a very strange kind. An attempt that tells the universe we are here. We are thinking. And we are searching for someone to answer. But the question that some scientists fear more than anything else is, what if we actually receive a reply that such signals are almost impossible to be random? For this reason, despite all our attempts, the cosmic silence remains one of the most puzzlings in the history of science. It is hard for many scientists to believe that a civilization advanced enough to understand its place in the galaxy would never try to say something or good something. We did it almost immediately. As soon as we had the technology, we began broadcasting. We started shouting into this vast void as if we were trying to prove our existence to the entire universe. So why aren't others doing the same? What is the reason for this silence? Perhaps the problem is simply us. Maybe our radio telescopes aren't pointed in the right direction. The galaxy is unimaginably vast, surrounded by billions of stars. Or perhaps our equipment isn't sensitive enough to detect the faint signals from deep space. And perhaps we aren't listening at the right time. A civilization might have sent its signal thousands of years ago, passing by Earth at the speed of light, while no one on this planet had a device capable of picking it up. Or perhaps their signals already arrived, but we didn't understand them. There is even a stranger possibility. What if they tried to communicate and then stopped because no one answered to it? But whatever the reasons, this lack of detection shouldn't discourage us, because the truth is simply that we are still at the beginning of the road. A few decades of observation mean almost nothing compared to the age of our civilization or the age of the universe itself. Oh? Take our own signals as an example. The oldest radio waves sent by humans are only 100 years old. Oh. That means for a century, they have been spreading through space at the speed of light, and now they have reached a distance of about 100 light years. This might seem like a huge number to us, but cosmically it only covers our immediate galactic neighborhood. 800 stars and planets. After another 100 years, our signals will reach a distance of 200 light years. And after 1,000 years, they will have traveled 1,000 light years. Even then, they will have covered only a tiny fraction of the Milky Way galaxy, a part that is barely 1% of its total size. But let's imagine the following scenario. Suppose a civilization living on a distant planet within this small corner of the galaxy picked up one of our signals 1,000 years from now. And let's assume they understood it and decided to reply immediately. This means we would have to wait 1,000 years. Imagine that for a moment. A simple message saying beep beep, hello, we are here. Bye. This message might have been sent 10,000 years ago, so will there still be humans after 10,000 years to receive it? Wouldn't fit? And if we replied, our response would take another 10,000 years to arrive. So will that civilization still exist after 20,000 years to hear our answer? Here, the real problem begins. Even within the borders of our own galaxy, and even at the speed of light itself, the distances remain terrifying. That is why communication between civilizations does not just require technology, but rather something much harder: patience. The patience of entire civilizations. This is also why our current search might be very limited due to the way we imagine life. Under the influence of science fiction, we always tend to imagine aliens as technologically advanced civilizations, possessing spacecraft and giant communication devices. But what if life in the universe were simpler than that, or stranger? Where life on Earth itself is not just represented by humans. The living world that surrounds us is mind-boggling to the point of being hard to grasp. Microorganisms, plants, entire oceans teeming with life, yet none of this sends signals into space. That is why scientists have begun to realize that the search for life should not be limited to intelligent civilizations only, but must include every possible form of life. We must search for their traces directly, about their chemical fingerprints, about the changes they leave in planetary atmospheres, about any tangible proof that something living exists out there. For a very long time, all this was merely assumptions. We logically assumed that the existence of billions of stars meant billions of planets. But we had no real proof until very recently. 1,500 years ago, everyone believed the Earth was the center of the universe. And 500 years ago, everyone thought the Earth was flat. Then, in a single moment of modern history, everything began to change again. Because humanity was finally able to see other worlds, real worlds already orbiting distant stars, For a very long time, the existence of planets around other stars was just a logical idea, nothing more. Nothing more. Yet there was no real evidence until the year 1995. In that year, everything changed. For the first time in history, scientists managed to confirm the existence of a planet orbiting a star other than our Sun. Its name was 51. Pegasi b, a massive gas giant similar to Jupiter orbiting its star at an astonishing speed. The discovery might seem simple today, but at the time it was like opening a new gateway to understanding the universe. Because we finally realized that our solar system is not a unique case M1L, that planets are not a privilege exclusive to our sun. Rather, the universe might be full of worlds. Suddenly, the question was no longer if other planets exist, but rather how many there are and what they look like. And could there be another Earth among them? But reaching those answers was never easy. For planets compared to their stars are extremely dark, bizarre. They do not shine on their own. They only reflect a very tiny portion of the light from the star they orbit. That is why trying to see them directly is like trying to see a tiny fly buzzing next to a giant spotlight thousands of light years away. Discovering the first exoplanet was an achievement, and a little bit of genius as well. Among the most clever and effective ways to discover these distant worlds, a stunning technique appeared, known as the transit method. The idea in its essence is surprisingly simple. Imagine you took out a small coin, then held it up in front of the sun. The moment the coin passes in front of the light, it will block a very small part of it. Now, imagine you have a highly sensitive device capable of measuring this very slight decrease in brightness. This is exactly what scientists do. When a planet passes in front of its star, from our perspective, the star's light drops by a very small percentage. A drop that is almost imperceptible, but it is enough to reveal the existence of an entire world. It is like a solar eclipse, or the transit of Venus and Mercury in front of it, but on a massive cosmic scale. With the development of technology, humanity began monitoring the sky this way continuously. Then the real explosion happened. After the launch of modern space telescopes, discoveries began to multiply at an astonishing speed. At first, tens of planets, then hundreds, then thousands. Today, scientists have spotted nearly 6,000 planets outside our solar system. And almost every month, more are added. But discovering the planet is only the beginning. The real question is what these worlds look like. What is their nature? What are they made of? And what secrets might it be hiding? Most importantly of all, could it be habitable? To answer these questions, telescopes have begun. Modern technology analyzes the finest possible details. When a planet crosses in front of its star, the amount of blocked light allows us to estimate its size, and from the frequency of these transits, we can deduce the orbital period. Then, by observing tiny wobbles in the star's movement, scientists can calculate the planet's mass. This is where the picture starts to become clear, because knowing both the size and mass reveals its density, and density tells us whether the planet is rocky like Earth or gaseous like Jupiter. We then calculate its distance from the star, the amount of heat it receives, and the nature of its potential atmosphere. To these complex calculations, worlds beyond imagination have begun to appear before us. Planets where it rains molten iron. Worlds where temperatures reach thousands of degrees. Europa evaporates just as water roars. There are other planets where temperatures fluctuate by hundreds of degrees between day and night in an instant, and giant spheres of burning gas orbiting their stars at breakneck speeds. A whole universe of strange worlds. But behind all these cosmic hellscapes, there is only one thing we are truly looking for. Another paradise. A planet resembling Earth. A small rocky world orbiting at just the right distance from its star, not too close to burn, and not too far to freeze. a place where liquid water could exist because water remains to this day the most important key to life as we know it. That is why every new discovery leads us back to the same question once again, Jen. Is there somewhere within this vast universe another planet that resembles our home? And if it truly exists, is there someone standing on its surface right now, looking up at the sky and wondering about us too? For example, it is difficult for us to imagine life existing on a metallic planet where rocks evaporate just as water does on Earth. But scientific history has taught us something very important. The universe does not care about what we can imagine. That is why we must always be prepared for surprises. When we talk about habitable planets, we are actually referring to something very specific. Habitable for us. Mars. We are looking for an Earth-like world, a world containing water, oxygen, moderate temperatures, and perhaps some vegetation. Woo! And honestly, we wouldn't mind if there were a small cafe at the end of the street overlooking a quiet lake at sunset. But finding such a cosmic paradise is not easy. Every newly discovered planet turns into an entire scientific dossier that requires years of study and analysis. This is why almost the entire scientific community is working in this massive race. Astronomers, physicists, geologists, and astrobiologists are all trying to answer the same question: what does a truly habitable world look like? Golden Age and E. And on Earth, radio astronomers continue, the very same ones who were searching for extraterrestrial messages to upgrade their telescopes to unprecedented levels. Giant facilities extending 4 miles, equipped with hypersensitive antennas capable of picking up the faintest signals coming from space. But this time the goal is no longer just to search for intelligent messages, but to search for something more subtle and more important, perhaps searching for the natural biosignatures of life. And among the most important things scientists are looking for today are the magnetic fields of planets. It might seem strange, but the existence of a magnetic field around a planet might be one of the most important conditions that allow life to persist. Because the magnetic field acts as a giant protective shield. It protects the planet from violent solar winds and high-energy particles that this star constantly ejects into space. Without this shield, the planet could be completely stripped of its atmosphere. This is likely what happened to the planet Mars. As for Earth, it has possessed a massive magnetic shield for billions of years, protecting its atmosphere and oceans from erosion. And when particles coming from the sun collide with this magnetic barrier, one of the most beautiful natural sights on our planet appears. The Aurora Borealis. That dancing light above the poles is not just a beautiful phenomenon, but proof that our planet is protected. That is why finding planets with similar magnetic fields could be very important news in the search for life. However, even this is not enough. Earth is not habitable only because it is protected, but because it breathes. It possesses an atmosphere rich in oxygen and a delicate chemical balance that allows living organisms to survive a new life. Only survive. And here, a whole new phase of research begins, the phase of analyzing the atmospheres of distant planets. So, this is exactly what the Ariel mission aims for in an advanced space telescope that will be launched into Earth's orbit to carry out an extremely ambitious mission, analyzing the air of distant worlds. not just to see the planets, but to know what their atmospheres are made of. Do they contain water vapor, oxygen, methane, or compounds that might indicate biological activity? But the most exciting part might lie in something else entirely. Imagine that scientists observed a certain planet for years. Then they noticed that the composition of its atmosphere changes over time, that the carbon dioxide ratio rises and falls regularly, or that oxygen is increasing in a way that is difficult to explain geologically. Then, that might mean there is something living that is changing its environment. Bacteria, plants, and perhaps animals. Only here does the planet turn from just a distant world into a living one. That is why what is happening today in astronomy is considered a real revolution. Because the old boundaries between sciences have begun to disappear, astronomy is no longer separate from biology, and geology is no longer separate from physics. To understand life in the universe, scientists have had to understand everything together. How do planets form? How do oceans originate? How does the atmosphere appear? And how does a dead rocky ball turn into a world teeming with life? It is a question that is not just about distant planets, but about the history of Earth itself. Because the answer might tell us something more profound than just the existence of life outside our planet. It might tell us how life began here in the first place. In space, no one can hear you scream. That famous line was not just a terrifying, cinematic phrase, but a reminder of a harsh truth. The universe is a terrifyingly silent universe. And perhaps this silence is not necessarily bad. For some scientists and thinkers believe that our uniqueness might be a blessing, and that finding an extraterrestrial civilization is not necessarily a happy event. What if they were not friendly? What if they were thousands or millions of years ahead of us? What if they looked at us the same way we look at insects or primitive creatures, Vana? Then it might be better if they never find us. You don't even know if this small planet exists at all. But there is another possibility, a more optimistic possibility. What if other civilizations were peaceful? What if the universe was full of beings that moved past wars and conflicts long ago? Civilizations that might teach us things beyond all our science fiction. The truth is, we don't know and no one knows. That is why, when artists and scientists try to imagine what extraterrestrials look like, the results are often amazing and very strange. In one artistic concept, the scene looks like a conference of beings that came from completely different worlds. A very small creature living inside a glass jar. It uses a mobile robotic frame to be able to communicate with others. And next to it are giant beings that may reach tens of meters in length. They evolved on planets with low gravity, so their massive bodies are no longer able to move easily within an Earth-like environment. But even these perceptions might be very limited because in the end we are prisoners of our earthly imagination. Everything we imagine is derived from life as we know it here, from animals, from plants, and from our own bodies. But what if life in other places was completely different from all that? What if it didn't look like anything we'd seen before? After many years of drawing and designing extraterrestrials, many artists and scientists admit that the real problem is not the limits of life in the universe, but the limits of our own imagination. That is why, if we really want to understand what life outside Earth might look like, we must first understand life here on our own planet. And this is where a new and incredibly exciting science begins. Astrobiology, the science that attempts to study life, not just as we know it, but as it could be. In the Netherlands, amidst cold sand dunes that seem completely barren at first glance, a Duden, astrobiologist Nicole Kappel stands before a very ordinary-looking scene. Some trees, a few plants, a gray winter sky. But when you look closely, an entirely different world appears. Tree trunks are covered with tiny lichens, and if we took a small piece of them and placed it under a microscope, we would discover an entire living system teeming with amazing microorganisms. And here emerges the truth that changed the way scientists think about life. Even in environments that seem completely dead, life always finds a way to appear. In burning deserts, in the depths of dark oceans under polar ice, and even inside rocks themselves. Life on Earth is much more stubborn than we thought. That is why astrobiologists began to wonder if life is capable of surviving in the harshest environments on our planet, then why wouldn't it be possible elsewhere? Why wouldn't it exist inside the frozen caves of Mars or in the oceans, hidden under the ice on some moons of Jupiter and Saturn? In fact, why not go even further than that? Why wouldn't life be able to even endure space itself? This specific question was behind one of the strangest of all the scientific experiments ever conducted. The expose experiment's idea seemed almost insane. Samples of various living organisms were placed on the exterior of the International Space Station, directly facing the harsh space environment without any real protection. Plant seeds, lichens, fungi, and different types of bacteria and single-celled organisms. Organisms. The goal was both simple and terrifying: to see what would remain alive. Space is not just a vacuum, it is a deadly place with violent cosmic radiation, extreme temperature fluctuations, near zero gravity, and no atmosphere to protect anything. Yet the results were shocking because a number of these organisms didn't just survive, they showed an amazing ability to resist space conditions. Some withstood lethal radiation, and others remained alive despite the near-complete vacuum. Here, scientists began to realize something very serious. Perhaps life as a concept is more resilient and widespread than we ever imagined. Then, perhaps if some earthly organisms could survive in space, life might be capable of traveling between worlds itself, and perhaps we are not the first to arrive here. This discovery was not a minor scientific detail, because those microplants, bacteria, microscopic organisms that survived in space are not just simple creatures. They are the foundation upon which all life on Earth was built. Every tree, every animal, and every human began one day from microscopic life forms similar to these women. And here the question becomes both terrifying and exciting at the same time. If these organisms are capable of withstanding the extreme conditions of space, could life itself be much more widespread than we believe? Could there be other life that has adapted to conditions completely different from those of Earth? Life that does not need oxygen or water in the way we know it, or perhaps life that doesn't resemble what we imagine at all. In fact, some scientists go much further. What if some life forms on Earth itself are more complex than we realize? What if there are entire communication systems between microorganisms, occurring all the time without us noticing? Hidden biological networks, collective intelligence, and methods of interaction that exceed our current understanding. The truth is that the limits of life in the universe may not be tied to what is possible, but only to what we can imagine. That is why, as science advances, the range of possibilities expands in a terrifying way. Microscopic life may flourish under the ice, inside rocks, in dark oceans, or even in space itself. And perhaps it is to us than we expect. In reality, the true scientific and tangible hope of finding extraterrestrial life may exist within our own solar system, not in distant galaxies, nor around stars thousands of light years away, but here, in our immediate cosmic neighborhood. Since humans began looking at the sky, the idea of extraterrestrial life has been associated with one planet more than any other world, Mars. Mars, the red planet perhaps, because its color resembles blood, or because its terrain looks strangely familiar. But for centuries, Mars has remained more than just a planet to humans. It was a possibility, the possibility of having neighbors in the universe. And more than 150 years ago, this idea became even crazier. Some old astronomical maps showed long lines on the surface of Mars. Scientists at the time thought they were artificial canals, likely built by intelligent beings. And so the legend of the Martians was born. But as science progressed, the truth gradually began to emerge. We've studied Mars from almost every angle. We sent probes to it and rovers that have been exploring its surface for decades. Today, these vehicles capture stunning images of a world that seems dead and silent. Endless red deserts, massive dust storms, giant mountains, and deep canyons. Yet we have found no conclusive evidence of life. But the search has not stopped. Quite the opposite. And people opposite. In recent years, the search for life within our solar system has become a top priority for space agencies around the world. But the real surprise is that scientists are no longer focusing only on planets, but on moons as well, specifically icy moons, because Earth is not the only world that has a moon. In fact, if we look around the solar system, we will discover that moons are everywhere, with Mars accompanied by Phobos and Deimos. But things become even more exciting near the giant planets, for there are entire worlds hidden inside the moons of Jupiter and Saturn, worlds completely covered in ice. But that ice, there may be vast oceans of liquid water, oceans deeper than all of Earth's oceans combined, And here scientists began to wonder, if there is water, energy, and the right chemical elements, why isn't there life? Some of these moons have even become the strongest candidates for hosting extraterrestrial life to today. For the first time in history, the question, are we alone, is no longer just a philosophical idea or science fiction. It has turned into a real scientific mission. A mission that could completely change the future of humanity. Because finding life, even if it were just bacteria under the ice of a distant moon, would mean something huge. That life is not a miracle that happened only once, but perhaps a cosmic law. As for Neptune, it has a large number of moons orbiting it, and Saturn has dozens of moons that vary in size, and their characteristics are amazingly diverse. But the most exciting planet is, perhaps, Jupiter. A giant so massive that some of its moons are larger than entire planets. For a long time, we thought these moons were just barren, cold, and dead, icy worlds. But science has begun to reveal something completely different. Fuel moons, in particular, have become the most important scientific targets in the search for extraterrestrial life. Enceladus and Europa. From the outside, the two worlds look almost identical. A completely frozen white surface, an icy desert that stretches endlessly. But under this ice, something amazing might be hiding. Because scientists believe that if we dig beneath the surface, perhaps just tens of kilometers down, we might find entire oceans of liquid water. Dark and relatively warm oceans, protected under a thick crust of ice. And this changes everything. Because liquid water remains, to this day, the essential element for life as we know it. But the most important question always remains, how can these oceans even stay liquid despite being so far from the sun? Here, one of the strangest phenomena in the solar system appears. Giant planets like Jupiter and Saturn possess gravity so immense it is hard to imagine. Their massive bulk generates violent tidal forces within their moons. As these moons constantly rotate, their inner layers are subjected to stretching, pressure, and friction. It is as if the giant planet is slowly squeezing its moon for billions of years. This internal friction generates heat that may be enough to keep entire oceans in a liquid state under the ice. And here is where it gets more exciting. Because the seabed might contain thermal activity similar to what we see in the depths of Earth's oceans, SETI, where entire living organisms thrive far away from sunlight. That is why some scientists have begun to speak seriously about the possibility of microbes or even entire primitive ecosystems within those dark oceans Habitable. And perhaps life is actually there right now. The great advantage of these worlds compared to distant planets outside the solar system is that we can reach them. We have been sending probes and spacecraft to the giant planets for decades. That is why space agencies have begun directing their interest directly toward these icy moons, In 2023, the European Space Agency launched one of its most important modern missions, the JUICE mission. An ambitious mission that will reach Jupiter's orbit in the coming years, carrying a massive suite of advanced scientific instruments. Among the most important of these tools is a radar capable of penetrating the ice itself, a device designed to see what cannot be seen, to look beneath the frozen crust and reveal the hidden oceans that might be hiding underneath the surface beneath. For the first time in history, we may soon possess direct images of another water world within our solar system, and perhaps evidence of the existence of life, even if it is just microscopic bacteria or very primitive organisms. This discovery will change everything. Change everything. Because it would mean that life did not appear only once on Earth, but rather evolved independently in another world as well. And this possibility alone carries immense meaning. Because if life could arise twice within a single solar system, what would stop that from happening millions or billions of times upon the universe? In the universe. Here, for the first time, the question shifts from, is there life beyond Earth there? To a much bolder question, how many living worlds actually exist right now in this universe? And with every new space mission, and every more advanced telescope, and every signal that reaches us from the distant, dark, humanity's eyes become sharper than ever before. We have finally begun to learn how to truly look at the universe. But perhaps the most important moment has not yet come, because the question is no longer just, is there someone else? But has become what will happen when we actually find them. We may one day discover a planet eerily similar to Earth ice, a world orbiting around a distant sun covered by clouds, with seasons shifting within it. In its atmosphere contains oxygen, methane, and water vapor. And then, it will not just be a new astronomical discovery, but perhaps the greatest moment in human history. If we find these elements combined and observe periodic changes in the atmosphere or the nature of the planet around its star, it could mean something living is moving there. Indeed, something breathing and changing and affects his world just as we do on Earth. And perhaps at some moment we will receive the first data from a distant telescope in space, revealing to us that the universe was never silent and that life was not exclusive to us. The search for extraterrestrial life has long transcended the boundaries of science fiction. It is no longer just stories about aliens or films about flying saucers. Today, it is real science and a massive global project, a question scientists are closer to answering than ever before. For more. In the coming years, we may discover the first alien bacteria, and in the coming decades, we may observe entire habitable worlds. Reaching them might take hundreds or even thousands of years, but that has never stopped humanity from trying. Perhaps a day will come when humanity becomes the first civilization to leave its original home and travel toward other suns, and perhaps we will be the first to break the silence. See, there is a strange possibility that cannot be ignored. What if we haven't found any other civilization because we are simply the first civilization to reach this stage? NEP stage. The first to learn how to send radio waves to the stars, the first to try to communicate with the universe. It is a terrifying and majestic thought at the same time. But there is another, even stranger possibility. The Milky Way galaxy may have witnessed countless civilizations over billions of years. Civilizations that arose, evolved, and discovered the stars. Then civilizations disappeared, living their cosmic solitude, believing they were alone, even though they never were. And perhaps this may be one of the most logical explanations for the famous Fermi Paradox. Where is everyone? Where? Perhaps they were actually here in the distant past, and perhaps they will come again in the future, but they are not here now. If that hypothesis is true, they might have already visited Earth millions of years ago, but there were no humans yet to see them. And perhaps in turn, they will reach us one day, but we will not be here to welcome them. Because time on cosmic scales is not measured in human years, but in millions and billions. That is why the survival of civilizations may be more important than their existence itself. Even if intelligent life emerged everywhere, civilizations might go extinct quickly before they can ever meet. When we look at Earth today, at the wars, climate change, divisions, and the immense power of destruction, the question becomes more dangerous than ever. Will humanity survive long enough to meet others in Benastan? Because discovering life in the universe will not depend solely on our ability to explore, but on our ability to endure. To endure for thousands of years, and perhaps for millions of years, to survive long enough to see what awaits us among the stars. And when that finally happens, when we stand before another civilization here, or somewhere far away within this galaxy, after all this silence and after all this long journey, what will we say, Dasa? Will our first question be, who are you? Or will we finally discover that the real question all along was, who are we? Adam?